like Terry said, I'm going to talk about mineral analysis. I know a lot of you aren't necessarily beef producers or any animal producers, so I'm going to try and keep it interesting because sometimes mineral talks can get kind of dry. But first, just a little bit of my background. So I did grow up in Laramie, and then I went back to school at the University of Wyoming. I decided to pursue a Bachelor's of Animal and Veterinary Sciences because I fed dairy cattle in Minnesota, and I just really fell in love with livestock industry. I went on to get a Master's in Animal Nutrition where I worked cooperatively with a scientist at US Mark. And currently I'm a professional member of the American Registry of Professional Animal Scientists, and I'm also a board member for the Near Infrared Spectroscopy Feed and Forage Consortium. So when it comes to the panel, if any of you guys have questions about NIR, it's something I get a lot day to day on the phone. I'll be willing to answer any of those. So I've been with Board Laboratories for 3 years now. Okay, so on to minerals. All right, so I kind of, yesterday I was up at the Goodmanson Sandhills lab, and I know a lot of you are probably familiar with Craig Uden of the DAR feedlot, and he said that one of the most important things that he does is make sure he has a good mineral program. And so that just shows you that people that are very experienced in the industry understand the importance of minerals. And so I'm going to try and hopefully by the end of today you'll understand that they're very important as well. So why are minerals important? We need to meet animal nutritional requirements to avoid any issues that are going to arise from deficiency or toxicity. And those aren't just going to show up as a deficiency symptoms or toxicity symptoms. They also might show up as that animal being more susceptible to infectious diseases as well. And so having a good mineral program is going to maximize your production, which ultimately is going to maximize your profits through animal performance, whether it's reproduction or growth, as well as less vet bills. Okay, so every minerals talk is going to show you this really confusing diagram with all of these arrows, and they're going to talk about, well, this interacts with this, and this interacts with this, and I just think that that is boring, and we're not going to get into that today because it can get very dry when you go through each individual mineral. So I am going to urge you, though, to take a look at our resource, the Ward Guide. Here we've compiled mineral nutrient requirements as well as toxic levels for many different livestock species. Today we're going to focus in on beef, mainly because that's who calls me and who I work with is the small-time cow-calf producer looking to dig into their mineral programs, whether it's just to make some overall improvements or because they are having issues. So we're going to see this later in the presentation, and as you can see, each of these species, their requirements are broken down based on their physiological state. So minerals are a lot more complicated, but lucky for us, the researchers have come before us to tell us we need to be between this level and this level to make sure our production is going to go smoothly. Okay, so this is where I'm going to try and ask of you guys a little bit. So these are some symptoms of a disease that's caused because of mineral issues. Okay, and so these are the symptoms: reduced milk yields and a weak skeletal structure. In an older animal, this is going to be considered osteomalacia, just like your grandparents are getting. And then in a younger animal, it might be rickets. Babies that don't get enough milk, maybe. So there's some hints for you. So the question is, which mineral or minerals could be responsible for causing these symptoms? Is it a calcium deficiency? Is it a phosphorus deficiency? Is it a phosphorus toxicity? Is it all of these things that could possibly cause it, or none of them? Okay, so the half of you that answered all of the above, you guys are absolutely correct. A calcium deficiency can cause rickets. Phosphorus deficiency also can, because phosphorus is so integral in how it builds bone mass. But a phosphorus toxicity also can, because phosphorus can actually block the absorption of calcium, and so you won't know if you aren't fully understanding how these minerals work together, and you're not balancing for the correct ratio, which is 2 to 1 of calcium to phosphorus needs to be in the mineral. You could add phosphorus thinking you've got a phosphorus deficiency and actually make a toxicity even worse. So that's the first question. So you guys did pretty good. Okay. So then this is the second question. So these are the symptoms: muscle tremors, staggering gait. This typically happens in the spring or on very rapidly growing forages. Hyperexcitability, convulsions, listlessness, the inability to stand, declining consciousness. It's referred to as grass tetany or milk fever, because typically it occurs in the spring when they're starting to lactate. Okay, so next question: which minerals could be responsible for milk fever? Could it be a calcium deficiency, a magnesium deficiency, potassium toxicity, both magnesium deficiency and potassium toxicity, or none of these minerals are playing any role in that disease? Okay. Yeah, you guys did really good on that. So a lot of people, I actually expected some of you to guess calcium deficiency. Since it's called milk fever, a lot of people associate calcium with milk. So that was kind of a trick, and nobody fell for it, so that's good. A magnesium deficiency absolutely can be one of the causes of it, and usually is the major cause of it. But what can contribute to a magnesium deficiency is a potassium toxicity, and a lot of you guys, being agronomists, may know that the plant doesn't absorb as much magnesium if there's too much potassium in the soil, and so it's the same for the animal. So if that plant doesn't have it because there's too much potassium, that plant also has too much potassium, and so the animal not only has magnesium deficiency from eating a deficient forage, but it also has that potassium toxicity, which is blocking the absorption of the magnesium, very similar to how plants behave with that circumstance. Okay, so this is going to be our last question. Okay, so these are the symptoms: a loss of pigmentation, loss of crimp in the hair wool, reduced growth rates, not thrifty animals, and reduced reproduction performance. And this one is probably the most common answer to the questions that I get. Producers often call me and they're like, we've been feeding the same thing for year after year, they were doing fine, and now it just seems like they're not breeding back at the rate that we'd like them to. So which mineral or minerals could be responsible for the reduced performance and discoloration of hair in black animals? Okay, well, it was half of you had gotten it right with all of the above. So yes, copper deficiency is the #1 deficiency across the country, and I have read about it this year in 2 different articles, one in Progressive Forage and then another one in the Wyoming Livestock Roundup. So this is a hot topic right now, is that copper deficiency is a problem in the beef industry right now. So hopefully the point I've made with those questions is that you can't diagnose based only on symptoms. You need to test the feed, you need to know what your animals are getting. And the best thing to do would be to test it for minerals and put together your mineral program and plan it before you run into any kind of issues. So this is actually an example from a real producer that I've worked with. And so just moving from this left to right, so he sent me his mineral tag. So we did not actually test the minerals in the mineral. We just went off the tag. That's a guaranteed analysis. He had a large pellet that he was supplementing, and so we tested the minerals there. And then he had 2 different hays, and he was doing 2 different diets he wasn't mixing the hay. So we have 2 different diets here, but the hay's mineral contents were very similar. And so I predicted these diets with the NRC equations for how much a mature beef cow at the lactation stage of production. Okay, so then we're going to compare these predicted diets. He didn't monitor his mineral intake, so we had to just go off what the tag said they were supposed to eat. But if you're running into an issue and you haven't been monitoring, you're going to realize right away you should have been. And you should already care about that because mineral's expensive, and if they're over consuming it, you don't want to be paying for that. And if they're under consuming it, then that might be an indicator that we need more salt in the diet, or we need to choose a different mineral. Okay? So, and then he did tell me how much pellets he was feeding per day, and then the hay was just open choice. So we just estimated, obviously I had the protein and energy content and the NDF, so estimated her intake based on her body weight. Okay, so the next thing we do, so we have these two diets here. We're just going to compare to our lactation phase requirements and our maximum tolerable levels to make sure that those minerals are meeting her requirements and not causing toxicity issues. And this was, she's just not, milk production is just not quite there. She's just not as thrifty as she was. My reproduction is off a little overall in the herd. So, it's not a real specific question. Okay? So the first thing I noticed about these when I put them up, so you can see there's no actual requirement listed for calcium and phosphorus. The NRC just says, please keep them the ratio between 2:1 and 1:1. And as you can see, we have way more calcium than phosphorus in the diet. So the first, in both of these diets, so the first thing to do was we need to add some more phosphorus to this diet. Okay? So then the second thing that stood out to me was that there's not very much salt in this diet. Sodium plays a critical role as an electrolyte, keeping the balance among the cells and all of that. So it was really critical to get that added in with that mineral. And then I also noticed that the magnesium, which also plays a critical role with calcium and phosphorus in bone building and milk and all of that, it was basically right at her requirements. And so just boosting that a little bit, especially when we have such high calcium, was going to help them out a little bit. So you can see that's kind of how you work those issues through. Now if you tested your hay before you chose your mineral program and your supplementation program, then you could avoid having to do this kind of workup after. So again, just to recap, minerals are very complicated. I showed you all of those interactions that can be there. But the best thing you can do is make sure you're between the requirements and the toxicities and everything's in the correct ratios. So we want to meet those animals' needs to avoid deficiency issues, toxicity issues, other health and production problems that are going to go along with that, and that's going to maximize our animals' production and ultimately our profits. So there's my contact information. Anyone has a question?
You guys able to test the difference between a nutrient that is absorbable and one that is not?
No, so we can only tell you the total amounts, but you're totally right. The bioavailable, the chelated minerals, putting those in, they're more expensive. Depending on what the mineral is, it's definitely worth it or not. And I have some good resources that if you email me, I can get them to you on that.
Are there any tests out there that do that?
No, not that I'm aware of.
Okay, we have a question on slide.
Oh.
Why is copper being looked at today? Is it because of lower levels in the feed source?
I don't know if it's because of lower levels in the feed source, but I think as research goes on and time goes on, we just have a better understanding of how everything's working. And before, where it was like, well, my reproduction rates went kind of down, I don't know what's going on here. Now that's more being identified as a copper issue. So I think that's part of it, but yeah. Hopefully that kind of answered the question. So, all right.
Okay, thank you.